Start this. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Meet again with you all in the financial data analytic class. And tonight, our topic is financial data analytics using RFM methods, recency, frequency, and monitoring. I believe when we have the PAL material class, if you recall, did we have the RFM subject there? Anybody recall? In PAL material topics?
Yes, we did, Pak.
Okay. Is there any assignment for RFM at the time?
Yes, I think so.
Okay.
If I'm
So
not
this
mistaken.
time we are going to do it in Python for financial data analytics using RFM methods using Python. At last time you use only using Excel, isn't it? Is it using Excel ya last time?
Yes,
or
Pak,
using
SPSS.
modular?
I think
SPSS.
and Excel.
Oh iya, SPSS modular ya?
Yes, Pak.
Okay. Alright. Okay.
Excuse me, sir.
Yes.
Sir, Artha says he is not able to join class today because he's at the airport.
Who?
Artha.
Artha, Pak.
Oh, I see. Okay, no worries. Wait a second. Carmel, last time you did not join the clustering class ya?
Who, Pak? Sorry?
Who?
Fahma. Emma.
Okay.
Emma didn't join the class for clustering ya, Emma?
Yes, Pak.
But you can see the video ya?
Yeah, I already asked Nana for previous class video.
I mean, you know the assignment ya?
Yes, I did.
Okay, so you already process the assignment?
On process, Pak.
Okay, good. Okay, so let's start the class. So in tonight class, we are going to do the RFM using Python. So what is the objectives of the class tonight is for you to understand what is the RFM and what are the RFM metrics, what are the RFM examples, what are the Rfm segmentation, how to do the validation, and there will be some demo on how to do the RFM modeling in Python. So RFM stands for recency, frequency, and monetary. This is the easiest form of customer database segmentation. This is the easiest form on segmenting the customer. Why do we need segmentation in financial data analytics? You see, on the clustering model, we segmentize the companies using financial ratios. In RFM, we segmentize the customer for each of the product. Let's say you have the saving account. In this product of the saving account, let's say this is a saving account in banking. In this product, on top of RFM, what is your campaign towards each of the segments using the RFM segmentation methods. In other product, let's say investment product, on top of RFM, what is the segmentation of the customer? Is it low recency, high recency, low frequency, mid frequency, high frequency, mid monetary, low monetary, high monetary? And if you combine the RFM, who is your customer, which is best customer? And then who is going to churn? And what is your campaign to drive them to better segment, to drive them to higher segment? So these methods can be used for campaigns for each of your products. Saving, investment, what else? Transfer, EDC, electronic data, EDC machine, yeah, electronic data. What is EDC? Electronic data. So to swap your car, yeah. So this is RFM. The RFM segmentation can be applied to activity-related data that has measurable value and is repeatable. That is having measurable value and repeatable. Let's say it is about e-commerce. In e-commerce, how do you transact in e-commerce? Let's say you transact using whatever. What is the tools that you use, the method you use for payment? Emma, how do you pay your e-commerce transaction? Using what?
Sometimes using virtual account from bank, Pak, or from OVO payment or
Okay,
GoPay
digital
payment.
wallet.
Yes.
Using OVO. So there will be your OVO number, OVO ID, and then your transactions, and then your values of transactions. How many times you orders, transaction order, yeah, and the values. So you can identify which customer, whether is Eva belongs to the high profile customer or low profile customer. Using the RFM, we can identify that whether Emma is high recency, or high frequency, or high monetary, yeah, or low recency, low frequency, or low monetary. How to bring Emma to the high profile customer? What kind of campaign do we need? Do the Bukalapak or Tokopedia, what kind of campaign that they need to do in order to bring Emma to higher profile customer? We can also use it in social media, gaming, lead management, yeah, using the purchase histories, the visits, and engagement. So the RFM is another way in segmenting the customer besides the clustering methods. Up until now, any questions?
No, Pak.
Okay, good. What is the metrics that we use in RFM? We use recency, meaning the freshness of customer activities. Yeah. With the indicator of how long does it take since the last activity with your company? How recent Emma towards on her activity towards the product or the company? How recent? And then the frequency of customer transaction. The frequency of customer transaction. How many times does Emma transact towards the product? How many times does Effie towards the company? And the indicator will be the total number of transactions. Number of transactions. And then matrix number 3 is monetary. The willingness to spend the money. And with the indicator of the total transaction value. How much money do Effie spend in the company? How much money that Effie transact in the product? So this is the matrix. But RFM matrix also can have multiple definition. There will be R, which there will be two definition, using total or using average. Using total, R is time since last transaction. Frequency, total number of transaction. Monetary, total transaction value using total. But this can also be average, which is R is time since the last transaction, the same. Frequency is the average time between transaction, meaning the average number of transaction. And then monetary is the average transaction value. In this point, using total, transaction can only increase customer value in segmentation. But in average, transaction can both could increase and decrease customer value in the segmentation. The total is more easy to explain, and the average is more complicated when doing the campaign. So there will be consequences when you use total or average. Let's say calculating the RFM matrix for each customer. Let's say the customer A, B, and C. So what is the product? Let's say EDC machine. Electronic data EDC machine, yeah. So customer A using the EDC machine, let's say 53 days ago. Yeah, 53 days ago with the frequency of 3 transactions and the monetary is 230. Customer B recency is 120 days ago with the frequency of 10 transactions and monetary 900. And customer C is 10 days ago. Frequency 1 transaction, but monetary only $20. Yeah. This is called the Rfm table, and it can be easily computed in SQL, or Spark is the other name of Python. So Python, not the other name. So the other um, advanced Python method. So after we get the Rfm table, so we are going to distribute the data for each of the metrics. Let's say in days, what is the minimum and maximum days? So their maximum is 120 and minimum is 10 days. So that will be around 110 days. 110 days. Yeah. So this is around maximum is 120 kah? This is 120. Okay. And then the orders min max 1 until 10. 1 until 10. And then the monetary 20 to 900. Okay. 20 to 900. 20 to 900. So all of the min max is there in the distribution. Next is splitting the values. Step number 3 is splitting the values into bins. In doing the binning, we need to quartile. We need to what we call quartile the data. Quartile the data. So what is the minimum, maximum, mid? Yeah. So that can be done in Python or SQL. So in simple way, we splitting the value into, let's say, 3 binning: segment 1, segment 2, and segment 3. Yeah. After we do the quartile usually. Let's say the quartile is around 0.25, 0.5, 0.75, and 1. Okay. Let's say below 0.25 is 1, 2, 3, and 4. This is how we do the quartile. Using the data, let's say the data is 1, 1, 1, 2, 2, 2, 3, 4, 5, 5, 5, 6, 6, 7, 8, 8, 8, 9, 10, something like that. We conduct quartile the data, quartiling the data. We separate into 4 classes. 1, 1, 2. This is 2 until 5. This is here. This is here. So we quartile the data, yeah, into 4. Or else we can do it for 3 until 0.3, 0.7. If you put using 3 segments, will be 0.35, 0.7, and then 1.0. Okay, below is 1, below is 2, below is 3. Yeah. So if we use 3 segments, so there will be 3 segments in here. Okay. For recency in days, there will be Emma. Let's say she has 100 days ago transact in the saving account, will be in segment 3. And then Effie 1 days ago transact in the saving account, will be segment 1. Okay. As also in orders, a lot of transaction, segment 6, 6 transaction in saving account per week, segment 3, segment 1 and 2. But the point is that this is only segmentation, not defining the score yet, only the segment. So we quantify the data using splitting the data into bins or binning. Okay. Yeah, this one is splitting the data into segments is by using quantiles. Yeah. So after you conduct the quantiles, yeah, you have the data like how many transaction? 1, 1, 1, 2, 2, 2, 3, 4, 4, 5, 6, 7, 7, 7, 8, 9, 9, and you sort the data 10, 11, 11, 12, something like that. So you quantile the data. This gives a starting point for a detailed analysis. 4 segments are more easy to grasp an action using quantiles. You can do 4 segments using quantiles or 3 segments. It is your call to do that. Next step. Survival analysis. Yeah. We are going to determine which customer, which segment has higher score. Let's say in the recency. Yeah. Recency, the more the time of transaction, the longer the time of transaction towards the current date, the lower the score. Or the more the time towards the current date, the higher the score. So you need to determine at first. Good customer will be high score or low score. Meaning, let's say, if the customer transaction is 1 month ago compared to yesterday, which customer get higher score? Let's say the customer with 10 days ago get 1, and customer with the yesterday transaction is 4. Or else upside down. The customer which is having yesterday transaction is 1 because he is number 1, and the customer which having 10 days ago is 4, ranking number 4. So it is your call which method do you want to use. Just like binary. Good is 1 or bad is 1. So it is your call to determine the methods. The same happen also to frequency and monitoring. High frequency, high score or low score. Yeah. So if the transaction is 10 compared to 1, 1 is 4, 10 is 1 because of the ranking. Or reverse into 1 transaction is 4, 1 transaction is 1, and 10 transaction is 4, high score. It's your call. So after that, we can put the RFM put the segments number to the Rfm table. So when you have a recency of 53 days, is it high score or low score? So if you put good is 1 and bad is 3, or good is 3, bad is 1. Okay, let's say we use this, yeah. Good is 3, bad is 1. Recency 10. 10 will be good. Yes. 3. 120 days is bad. No, bad. Okay. Need to check. Is 1. 53 will be 2. 10 transaction is 3. Okay, good. Oh, wait a second. 3 good. 3 transaction is 2. 1 transaction is 1. Okay. Monetary 900 is 3. 230 is 2. And 20 is 1. So we got as what we call segmented Rfm table. Yeah. The Rfm table if is kinda like this, yeah. So we can visualize them into segment like this, what we call a stack tables. We can use a stack contingency table to count customer in each of the segment. To count. The objective of stack table is to count number of customer in each segment and compute summary statistics. Let's say, so you have the Rfm table for each of the customer. Customer A, B, C until 1000. You have the Rfm score. The Rfm score, if using the score will be 222, 133, 311, something like that. We put it into the stack contingency table. How many customer which is having 111? Oh, there is 5 customer. How many customer having 112? 7 customer. Having 113, 2 customer. 114, 3 customer. So this is the objective is to count the number of customer in each segment. The best customer will be only 3, 4, and 4. If you use the maximum amount, yeah. If you use 4 is the highest, and 3 is the highest for recency, and 4 the highest for frequency and monetary. So this is the best customer if using the highest number. But if using lowest number, meaning this is the best customer. 1 recency is very high, very near time on the transaction, very recent in transaction, and 1 frequency is the highest transaction, and 1 monetary is the highest monetary. So this will be the best. It depends on how you define the good and bad on the Rfm score. So far so good. Any questions?
No, sir.
No, sir.
All good. Yeah. So okay. Therefore, after using the RFM segmentation, we identify which customer is churn, which customer is at risk, and which customer is active. And the campaign towards the group of segment is different. You develop your campaign accordingly with their situation. For a customer within the churn condition, how do you campaign? For the customer at risk, what kind of campaign you gonna do? And the customer which is active, how to drive them into more active customer. Yeah. So for the churn, how do you conduct the reactivation campaign? For the company customer at risk, retention campaign, how you retain them, and for customer which is already active, how you conduct the cross-selling and promotional campaign. So in the financial data analytics, our project is also how to achieve the bottom line. How to achieve the bottom line using the RFM segmentation. You need to make sure that the sales forecast is achieved, can be achieved using selected campaign accordingly with the customer segment. Yeah. So in financial analytics, you need to make sure that the campaign, the activity is efficient accordingly with budget, because you have scarcity of capital. In financial data analytics, we understand that the company have scarcity of capital. We cannot spend our money. We only have limited amount of money. We need to spend our money efficiently. So you need to conduct campaign that is not in mass campaign, but more into specific campaign accordingly with the customer stage, whether they are churning, whether they are at risk, or whether they are active. We need to make sure that our budget can cover until end of the year as a finance analyst in whatever the company. And then after we got the number of customer within each of the segment, we can label them. What is their persona? We can label them as a premium customer, gold customer, or silver customer. You can name it accordingly with your appetite. This is basically the persona of the customer. Yeah. Yeah, this is the persona. In turn, customer in the premium customer needs more budget to bring them back to the company. Premium customer at risk need more budget to bring them back to the company or to retain them within the product. Active customer, you need to be not to spend more money, but just to make sure that they are going into higher position, whether from fresher, going to standard, going to silver, going to gold, and up until the premium. With the RFM matrix based on sum of events, the move can only be towards higher value segments. How do you verify your RFM segmentation? You can do it using the training and testing. Split your data into two parts. Yeah, in the training period, you identify the profile of the segments, and in the testing period, you conduct your campaign, and whether they are from churning back to the company or from at risk stay in the company, and for the active, be more active. So we can, after we have the training data, and then we conduct campaign and see in the testing period, yeah, what happened to them. Okay. One, you can also use A/B testing on top of training and testing. A/B testing is you split the data into two, and then one data you do as business as usual. The other data you conduct specific campaign. For business as usual, what is the result on the testing period? And for you do campaign accordingly with their profile, what is the performance within the test period? Comparing the bottom line, which one is better off in delivering the value to the company. Any questions? Capish?
Pronto, Pak.
Okay. Yeah. Same. Okay. Let's go to the Kegel. So I already share, yeah, the in my Kaggle. You can check into the in my Kaggle, and then there will be I have 40 codes here. I have the RFM analysis tutorial. Okay, this one is the RFM analysis tutorial. Okay. So all right. So in RFM analysis tutorial, as usual, we import pandas SPD. Okay, let me open it here for a second. Okay, edit. Can you all see my Kaggle?
Yes, Pak.
Okay.
Yes, Pak.
All right. Let's run all. Okay, while in process. So in RFM analysis, well, we cannot. So the first one is that we need to, as usual, we need to import pandas. SPD import datetime as DT, import numpy as NP, import matplotlib.pyplot as PLT. Why do we need to import datetime? So this one is to be able to calculate on the recency, yeah, because it is using datetime. Yeah. Okay, running, and then let's read the data. I have the input retail data transaction with the parse dates. Parse date is the trans date, meaning what is your current date. Today is 2022, so we can use 2022 as the target date for the gap between transaction and the targeted date. We can also determine what is the transaction date, the parse date for the transaction, depend on the data. So we have, if we put the, we read the CSV file, and then this is the head of the data head. There is on the data, there is customer ID, customer date, and transaction amount. Let's say this is the EDC machine data. The customer ID is your debit card, and then the transaction date is there, and the amount of money, $35. This is your data. Okay. And then we find the information about the data. We get 3 variable, which is customer ID, transaction date, which contain date time, and transaction amount, integer data, yeah, integer data, date time data, and object data. Okay, let's assume that the study is being done on the target time for the recency is April 1st, 2015. Yeah, so we need to identify what is the min max of the dates of the transaction. What is the earliest, meaning the minimum towards the April 1st, 2015, and the latest, meaning the maximum gaps on the date. So we print data frame of transaction date dot minimum, ya, bracket, comma, data frame of transaction date dot max, bracket. So we identify that the minimum transaction date is on 2011. Okay, 4 years ago, May, and the date of 15. When we use the parser date, when we import the parser dates here, the date time using the parse date, it is starting from the high first, meaning year first. Yeah, year, month, and day. Year, month, and day. Cannot months first or day first. No, years first. Years, months, and day. So this is the minimum, the longest gap, meaning, and the max. 2015, January, February, March, 16th of March. So this is the closest one, the max. So towards the April 1st, 2015. Okay, now we understand what is the max.
Pak,
Yes, Effie?
this is Emma, Pak.
Oh yeah, Emma?
Pak, for minimum and maximum,
Mhm.
it's showing 2 dates, right? On 16 May 2011 and 16 March 2015.
Yes, the mix,
And
the transaction date, yeah?
yeah, but then on the next coding, there's no data showing 16 March 2015, Pak.
16 March 2015?
Yeah,
Oh,
only 15 March 2015.
you mean in here?
Yeah,
Because this is only head.
what do you mean by that?
Head only top five row.
Oh,
So
okay,
the row
okay.
is around to 125,000 entries. This is big data. Yeah, so plenty of data. Yeah, the transaction data here. So this is only top 5. If you're using head, if there is no number here, only 5 data come out. Only top 5 row will come, will be printed. Araso, Emma?
Okay, Pak Araso. Thank you,
Okay.
Pak.
Okay, good. We have getting the minimum and maximum transaction date. And then the current date is 2015, months is 4, day is 1. So we set the SD as the DT because we already input the date time as DT. DT dot date time 2015, comma, months is 4, comma, and 1. This is the current date. So this is our targeted date to calculate the gap on the days. So data frame of history equal to standard date minus the data frame of the transaction date. This is the transaction date. This is the standard date. Standard date is 2015 for months 4 and day 1. So the data frame of his or history is standard date minus the transaction date. Yeah. And data history, okay, is using S type time delta 64. This is the standard type of data, and equal to data frame of history divided by the numpy dot time delta 64. And then we see the recency, how many days towards the towards the standard date. So we let's see the data frame head after we add history in the data. So in the data frame, we add one more column, which is history. And then we see what is the gap between standard date towards the transaction date. Okay, the transaction date is 2013, months 2, day 11. Yeah. History is the standard date is 2015, months 4, day 1. So the gap is 779 days. So Emma has not been transacting with us for almost 2 years. This is Emma. This is Effie. Effie 17 days ago transact with us. So we get another data here. Giving the transaction date, we calculate the recency using the word of history. And then we want to transact to calculate only the transaction that happened in the last 2 years. 1 year is 365 days. So if you only calculate the 2 years transaction, meaning the data frame, yeah, on history supposedly below 730 days. So we drop the data into the data where the history is below 730 days. So the data only after we drop the data, we only have 63,633 entries. Only 63,000 data. And the data is there in customer ID, transaction date, trans amount, integer data, and history data, float data. The data will be summarized at customer level. So we want to group by the data because every transact 20 times, 30 times, 73 times, yeah. Every can transact many times in Transmart using her card. Swipe EDC machine, in a year. In the last 2 years, maybe she have 20 times coming to the Transmart. So we need to group by the data based on customer ID. Within this customer ID, what is his or her last transaction? Meaning their minimum, yeah, minimum recency. And then in the customer, how many times does Effie come to the mall? So from the customer ID, how many customer ID? How many customer ID happened in the last 2 years? So we use customer ID lambda x ln x for frequency. And the volume for transaction amount, we need to summarize the transaction amount. So we need to develop the Rfm table where it is from the data frame grouped by the customer ID and aggregate. This is the aggregate level data, and we need to aggregate, yeah, from history what is their minimum transaction, minimum date time, and then how many times the customer ID visit to the do transaction in the Transmart, and then what is the summary of the transaction amount. So after we run that, lambda replacing bound variable x with the arguments. And then let's see how the Rfm table develop. So we can see that this is FE. FE having 10 times, but the minimum dead time is 77 days ago. And then the customer ID visit Transmart 6 times in the last 2 years, and transaction amount is 359. So this is the aggregate level data. So every customer now by the stand alone there. Evi, Emma, Arta, ya, Wania, Givari. So this is the aggregate level data. After we get the aggregate level data of the Rfm table, we rename accordingly with the Rfm model. His we rename, so Rfm table rename columns equal to history, we get change to recency, customer ID to frequency, transaction amount to monetary value. In place equal true. So this is true. And let's see what is the Rfm table, the new Rfm table look like. So we have all the aggregate level data, recency, frequency, and monetary. So we have the data here. From the transaction date, transaction amount. Now we get the Rfm table. And then we need to, if we want to check, to validate, we need to do some validation. Okay, let's open FE data. Data frame of customer ID. FE is like this. Okay. Customer ID is like this. This is the transaction number and then transaction date. So FE has done some 1, 2, 3, 4, 5, 6 times transaction in Transmart with the transaction amount is like this, and then the distance on the time is like this. The longest time is 639 days ago, and the recent one is 77 days ago. So this is only to do the validation to make sure whether the data is correct. 77 days, okay, correct. 1, 2, 3, 4, 5, 6, 6 is correct. Monetary value 39 plus 90 plus 63 is 358, correct. So this is conducting the validation on the data. We need to do this, 1 or 2, to make sure that the data is correct accordingly with the fact data. Now we have validate the data, then we need to do the binning. We need to quartile the data. I use, let's say we use 1, 2, 3, 4. So we conduct quartile using quartile 0.24, 0.50, 0.75. Yeah. So we have on this data. On the 0.25 of the data, on the frequency, it is there in 38. 0.5, the middle data is 69 days ago. 0.75 is 127 days ago. So if the customer range of date towards the standard date is below 38, we consider it, let's say we put the highest score, highest score in the, lowest score in the good one. So if below 38, then the score is 1. 38 until 69, the score is 2. 69 to 127, the score is 3. Above 127 is 4. Bad customer. Frequency, the good frequency is 1. So above 11 is 1. 11 till 9 is 2. 9 to 7 is 3. Below 7 is 4. Monetary value, above 796 is 1. Below, between 700 and 500 is 2. Below is 3. Below is 4. So this is the quartile data on the recency, frequency, and monetary. After we got this number, yeah, okay, we after we got this number, we can see, okay, we can see on the quartiles like this. Recency on 0.25 is 38, 69, 127. So this is the quartile data. Yeah. In case of recency, lower is better. So it is different than frequency and monetary, which lower is worse. In recency, lower is better. Now we need to determine the score for each of the variable, recency, frequency, and monetary. So in recency, if it is below 0.25, recency, the return is 4. Okay, let's see. Okay, this means that more recent, the score is higher. So we are using 4. And the longer the time, the return is 1. Also on the frequency and monetary. Below 0.25 is 1, above 0.75 is 3, else 4. So we have the standard. We define the recency and frequency monetary score. After that, we want to develop the Rfm segmentation. Yeah, using the Rfm table, where on the R quartile is the Rfm segmentation. When on the recency quartile, we use the recency dot apply arguments recency dot quartile, so we can we use the R class, Rfm class. This is the R class, yeah, using the score that we set up in R class and Fm class. So we develop the R quartile, frequency quartile, and monetary quartile. 211, 333. So 77 is 2 because above 38. 6 is 1, low score. 358 is 1, low score. So we got the Rfm segmentation head, the top 5 row on the Rfm. And then we need also to develop Rfm class, combining the number 211. On the Rfm segmentation, we create one more column, which is Rfm class equal to Rfm segmentation of R quartile string, and then plus Rfm segmentation on F quartile string plus quartile string. So we got the Rfm class is 211, 333, etc. So this is the Rfm segmentation head. We got the data already. Okay. After we got the Rfm segmentation head, top 5 like this, We have the recency, frequency, monetary, and then this is R quartile, F quartile, M quartile, and RFM class. So we sort the data from the bad until the good. So the best one is 444. The best one. Who are the best customer? Who are the worst customer? Who is customer it is going to churn? Who is the customer in at risk? Who is the customer inactive? So when we sort the data, sort Rfm segmentation dot sort values by Rfm class. From Rfm class, we sort the data. So when you have this, you can export this to Excel to develop your stack, full stack. So this is also using the mean. That was in using total. This is using the means. So what is the monetary values? The means in each of the class. Rfm segmentation group by Rfm class with the aggregate on the monetary value means. What is the means average monetary value on the 111? Oh, $230. On 444, $1,000. This is the average on the monetary value. You can also do this towards the frequency or towards the recency. And then, okay, this is the Rfm class and how many people there, total score. How many people? Total score, total score is the adding on the 2 plus 1 plus 1, it is 4. So this is still segmentation using the combination of string number or total number. So this is also up to you to choose whether to use the combining string number or total score. Basically, this is just the adding 2 plus 1 plus 1, it is 4. After that, you have the Rfm class and total score, the new data. Rfm segmentation dot head, we all had the data, frequency, recency, frequency, monetary, R quartile, F quartile, M quartile, Rfm class, and total score. So we can also aggregate monetary values like this, the same with the above, and we can also checking with the
sorry, sir.
yes, Vanya?
Can you scroll up the table? Can you tell me how to read that table? The total score table?
Which one? This one?
This table, the head
This
table.
one? This one, Vanya? Vanya? Do you mean this one?
Further down, Pak, the total score, I think.
Total score. This one?
Yes, sir.
Oh,
Sorry,
okay.
my internet's poor.
Group by the total score. Previously, we group by the Rfm class. This one is group by Rfm class. So the data group by. So there is 444. In group by, we only have 1444. This is
Okay. And then here, 444 is optimal, right?
Yeah, the 444 is only one because we group by the 444 from, let's say, from 20 data. From 20 data of 444, we group by into one. We got the average monetary value of $1,000. That is the function of group by. Okay, Vanya?
Okay, sir. Thank you.
All right. So we can also group by total score. On total score 12, this is the average number. Compared to 111, we have a lot of combination, yeah. How many combination is there? Yeah, around 50 kah. But if you use score, we can only have 1, 2, 3, 4, 5, 6, 12. Apa? 9 combination. Yeah, 9 segments. 9 segments. If we combine the string data 413, 421, if we combine this one, we still get plenty of segments. What are you going to do with 111? What are you going to do with 432? What are you going to do with 333? Yeah. But if you do it in the full stack, yeah, you can also grouping the segments, put it into churning, at risk or active or whatever. If using total score, we can have nine segments. Yeah, this is more easier. This using the total, yeah, more easier. What are you going to do with segment 3, segment 4, segment 5, segment 12? What are you going to do with them? Okay, so in order to make sure that our scarcity of capital being used efficiently, don't put all your money to all customer. No, you need to put accordingly with their needs and wants. Yeah. To make sure the optimum result from your scarcity of capital. And then this is how to visualize the data. Group by the total score and aggregate with the mean of the monetary value. With the bar and color map is blue. Also, we can do that on the frequency and on the recency. Total score of 3, yeah, meaning what is the average recency? What is their mean recency on the each of the total score? Oh, recency for the 12 recency is very low. Oh, very good, something like that. On the days, I'm sorry. The good one is the small number or big number? Small number, yeah. The good one is the small or big number? Oh, the
For recency, small, right?
recency is 4 is 27. Oh, big number is good. Yeah, the big number is good. Big is good. Small is bad. Okay, something like that. Okay, so we have visualized the recency, frequency, and monetary. Okay, so we have the data, and then what is this? Promotion of the respondents. Yeah. Yep. So you can send the data into you can so you can have you can calculate based on RFM class, or you can calculate based on total score on how many customer is there. Yeah. So this is how you do the RFM analysis using Python. Any questions?
Pak, sorry.
Yes, Emma.
Back to the value of quartile. Is it always the multiple of 0.25, or how we can determine that?
Okay. Alright. On the quartile, you can select your own. You can put 0.3 and 0.7 quantile, yeah. You can change, let's say you want only 3 segments. You do 0.30 and 0.35 and comma 0.70. So we have a quantile into 3 segments. Below 0.35, 0.35 until 0.7, and above 0.7 until 1. So you got 3 segments. It is in here where you can set it up. Araso, Emma?
But it's only always below 1, Pak.
Come again?
The value always below 1.
The value always below 1, yes. Because the concept is, where is it? Let's see. On the quantile, I think I already explained it before, yeah. This one. So you sort the data from the very small until the biggest one. Yeah, let's say this is the transaction. Yeah. So basically this is 0. This is 1. So you want to quantile into 4 segments, or you want to quantile into 3 segments. That's your call. If you want to do it until only 3 segments, meaning 0.35, 0.7. Yeah, something like that. So below 0.25 is 1, 1, 1, 2, 2, 2, 2, 4, 4, 4, something like this. So this one is until 0.35. This one until 0.70, and this is segment 1, segment 2, and segment 3. So it depends on how you put the number into the quantile data. Araso, Emma?
Pak. So if I start with 0.20 and then 0.40, is it multiple by 0.20? Is it okay, Pak?
No, you need to distribute evenly. If this is 0 to 25, 0.5, 0.75, evenly distributed, isn't it?
Yeah.
So if you want to have 3 segments, meaning 0.33, and then 0.66, something like that. 3 segments. If you want to put 5 segments, 0.
Sorry, Pak, maybe,
Yeah.
sorry, Pak, maybe what Emma said, if we want to divide it as 5 segments, so
0.2.
yeah,
Yeah.
so it can be done, right,
Yes,
Pak?
can be done. You want to
Yeah.
do it in 5,
Okay.
0.2, 0.4, 0.6, 0.8, something like that. So,
Okay.
okay. Continue. Yeah. So, if you want to have it in 5, okay, in 5, meaning 0.2, 0.4, 0.6, 0.8. This is 1, 2, 3, 4, 5 segment. Below 0.2, 0.2 until 0.4, 0.4 until 0.6, 0.6 until 0.8, 0.8 until 1. Araso, Emma?
Araso, Pak.
Okay,
Thank you, Pak.
good. Any other questions?
Sorry Pak Jerry for late join this class.
Okay.
Uh, uh, is it should start with 0 point? Is,
I cannot hear you, Arta.
ya Pak, we should start with 0 point something Pak.
If of course. No, you need to. How many segment do you want? 3 segment, 4 segment, or 5 segment? If you want to do it in 3 segment, okay, this one again. Let me. Okay, if you want to do it in 3 segment, meaning the quantile is 0.33, 0.66. If you want to do it in 4 segments, meaning you have to do it in 0.25, 0.5, 0.75. If you do it in 5 segments, meaning you have to do it in 0.2, 0.4, 0.6, 0.8. Araso Arta?
Araso Pak. So in the total should one ya Pak ya.
The objective is to make sure the data distribute evenly. Because the data, let's say there is 100 data. Meaning this is 50. This is 50. If 4 segment, this is 3 data, sorry. 3 data, 30, 30, 30, something like that. So we need, why we do quantile, is to make sure that the data is distributed evenly towards the classes. The class of 0 until 0.33 is 30 data. 33 to 766 is 30 data. 66 to 100 to 1 is 30 data. Araso?
What if the number of data is not 100 Pak?
Come again, Arta?
The number of the data is not 100.
Yeah, you can say 150. So we need 50. 50. 50. Got it?
Oh, got it, Pak.
Okay.
Thank you Pak Jani.
Good. Any other question? So basically this is just converting from the SPSS towards Python. In SPSS, it is drag and drop. In Python, this is using a lot of function. Yeah, we are involved in deeper communication with Python in order to develop the RFM model. Yeah. All good? Capish? Any more questions? Any more questions? Araso?
I'm good, Pak.
Okay. So, regarding the clustering, next week can you start presenting the assignment?
Is it supposed to be 4?
Supposed to be 14th of September, Pak.
Yeah, 14th of September you submit the journal then. You submit all to the Moodle ya. Oh, 14 ya?
Yeah.
Yeah, 14.
Yeah,
14 is
14.
to the deadline. But you can also you can present it if you already done it. If you already done it, next week you can present your assignment. Yeah. Next week will be on the 7th kah? Okay, so next week we
Yes,
are
yes.
going to have the class in Friday as well because I have a matriculation in the Wednesday and Thursday in MM Bakri matriculation for the new class. So I moved the
Student,
class
yeah.
to Friday. No worries, yeah.
Noted, Pak.
Yes, sir.
Okay. And next week you can start the presenting, and then I can also check the journal, and then and after I check, you can submit it to the Moodle next week. Yeah, the deadline is the 14th. Yeah, no worries. Okay, the point in my class is that you can publish it to Scopus. I'm not just giving numbers, but I'm interested in you publishing it in Scopus. So I want you to really develop your journal with a high standard. Yeah. Some of the students in previous class already published in Scopus. Yeah. So there is achievements in your assignment. Yeah. If you publish, the score will be definitely A minus. Araso?
Sorry Pak,
Yes.
can you repeat Pak?
If you,
About
okay, if you can publish your journal in Scopus, yeah, guarantee will be A.
How about if it's published in Sinta 1 or Sinta 2, Pak?
Oh, that's okay, A.
Oh, it's okay. Okay.
Yeah.
As long as published, ya, Pak.
Yeah, as long as it is published,
Okay.
then I guarantee A. Not saying that if you are not published, you are not going to get A. You can still get A, no worries, because the publisher, it is beyond our control. Yeah, it is not within our control because it is them who want to who reviews and check. So make sure
Yeah.
when they have reviews, I get the reviews as well. That's why I put my name in the second author, so I can check what is the review on the publisher, for us to hand in hand together make sure that your journal published in Scopus. Okay, cool. So no other questions?
me Pak.
Yes.
Sorry Pak,
Apa?
ada question. The about the assessment Pak. I see the Moodle we should choose one out of three ya,
Yeah,
Pak.
I already select clustering.
Oh, clustering based on financial ratio ya, Pak.
Yeah, you joined the class last week, yeah?
Yeah.
Yes, watch again the videos, yeah, on how to do it. So select their industry using the IDX data, and then select the financial ratios. I put there already in the assignment, yeah. You haven't starting it yet, Arta?
Not yet, Pak.
Come on. Okay.
Yeah.
Okay.
Yeah, Pak.
All right. So no other questions? Good. So let's have the post test.